All right. Well, thank you all for taking time out of your day to come learn about what's going on with MeTTaCycle. Um, I have a brief diagrammatic introduction. Let's see if I can find it. Yes, here we are. I will quickly share this and then turn it over to demos before we do any discussion. So there are a lot of terms floating around, and probably people are confused as to what refers to what. Um, so let me help unconfuse things. Firefly is a software stack. The software stack can be used to build an extremely scalable blockchain. I tend to refer to it as a digital asset management system, where the digital assets can be things like healthcare records or audio files, like WAV files or video files like MP4 files. Um, and then MeTTaCycle sits above that. And the main feature of MeTTaCycle above Firefly is the compiler from Meta, the language Meta developed by the SNet group, to Rolang. And it's not just Rolang, it's Rolang plus PathMap. Um, so PathMap is a data structure that was developed by the Mort group that makes it possible to do very, very fast, efficient indexed queries. And then, yes, was there a question? Okay. But again, that's a software stack. So these two layers are software stacks. And then what ASI chain brings to the picture primarily is machines. So ASI chain, being a chain, commits to making sure that the software is running and available to whatever community it's serving 24/7. So this is mostly about hardware. They've added a few bits and baubles that actually we also have versions of down here in this stack, such as a block explorer or a wallet. We have both of those down here, but they've also added their variations up here. So the primary value at the ASI chain level is a commitment to hardware running 24/7 that is running this software here. Any questions about that? Does that make sense to folks?
It does. I have a question though.
Go for it.
So I just wanted to rate it currently when you're talking about the two lower layers there,
Mhm.
MeTaCycle and Firefly, right? We've got a meta compiler that goes to Rolang and PathMap,
Mhm.
and that's MetaIL, I assume, right?
No, MetaIL is just right now the compiler short circuits any path through MetaIL. It will as MetaIL gets, and you'll see some demos for MetaIL. But as MetaIL gets more and more mature, then the compiler will be expanded to take advantage of that. But MetaIL is really Rolang 1.3. That's what it is. It just has a funny code name. And what it does is it solves a number of things all at once. On the one hand, we've been looking for an input language to run our algorithms for generating spatial behavioral type systems. So MetaIL is that. That turns out to also solve Ben's requirement. He wanted to sort of have programmable type systems. So it does that. And it does a few other things. But right now, the meta compiler just goes straight to Rolang 1.2 with path map added. And then in the next few months, as MetaIL progresses, then the meta compiler will avail itself of those types. type system generators. Does that make sense, Charlie?
It does. I guess, in terms of once MeTTaIL Rolang 1.3 are production ready or close to it,
Yeah.
then there are other options to compile target wise, right? Like PETA, for instance, is that a possibility or am I off base here?
You could certainly do that. So let's think about what that would do. I don't want to go too far off topic here, but
Sure.
um, so PETA is really just a compiler from Meta to Prolog. So if you really wanted the Prolog underneath, then you could write down the WAM, the Warren Abstract Machine that is used for executing Prolog. You could write down a description of the WAM in MeTTaIL, and then you could write a compiler from Meta to the Warren Abstract Machine. That would be a compilation path.
Thank you.
Mhm. Okay. All right. So with that, let me turn our attention to what our demos and what you're about to see. So you're going to see 3 or 4 different technologies, um, four technologies to be precise. So the first one is a demonstration of what we mean by digital asset management. So uh, we have created a blockchain as a file system application. So the architecture is roughly this. We're changing it for the different OSs, but currently the way it works is we have libfuse, which drops a device driver down into the kernel to catch file events. And then it shuttles those file events up to the user space so that ordinary programs can handle those file events. So then we have a little adapter layer written, I believe, in Java right now or Scala. I think it's probably Java. That then takes those file events and turns them into operations on a Firefly shard. It looks like there are 2 more people in the waiting room. Um, and so the metaphor is that an address on a blockchain represents either a file or a directory. So you can store files and other kinds of content directly on chain. And then we also have extended the metaphor so that denominations of tokens can be represented as files. So for example, suppose at an address you had 1,000 staking tokens. Then you could represent those as 10 100 token files, or you could represent them as 110 token files. And we have modified the file browsers when you install FireDrive, which is the application, to allow you to make change. So you can literally turn your file browser into a point of sale system if you were so inclined. Um, so with that, let me turn it over to Andrei Stefanov, who is on the call, who will demonstrate for you FireDrive.
Um, yep. Hello, everyone. I will share my screen a moment. Yes. So, here is like local environment just for demos. I will close it. I'm just showing like I'm having few nodes running, and actually the main application is here. It's Java application. Yeah, it's our FireDrive application. I will keep it here to show some interactions. So it's just logs. And the UI of it is like this icon or this location in a Finder, the same as Google Drive. So once I click in, I can see something from my Google Drive account. And the same when I mount this Fire Drive, I can view some addresses. The first one is mine, that I provided a private key and a ref address on startup and when we started. And here there is some more external addresses. So basically the first one is just regular folder. I can go to this folder and interact with the regular folder, like creating something. So I can create images here, also audios. And in background, it's using rolling and saving these folders and state on the chain using deployment to the observer to the validator. Yeah, so in background saving, and I can interact like this is on a chain. This is my local storage, so I can drag and drop like some image, and inside images can open, and now I can screen face preview. I can open from my from chain folder, and it's the same for audio. I can like drag and drop an MP3 file, and it's saving in background to the chain. Yeah, so this is like one of the main feature to work with my address as it like my folder on the chain. And another feature, I can also view another addresses. For example, a moment, with G. This one is also mine, but it's locked. So once I want to interact with this, I need to provide private key that is saying that on another window. Sorry. And yeah, providing private key, unlocking it. And I can like, I'm having two unlocked folders, so I can interact with both, creating something as well. Yeah, so it's another feature. And
You want to show the tokens?
yeah, and tokens. So here's like two folders, but when I hit the show hidden folders, there is another one called tokens. It's present for all addresses, like here and here. So, and it contains files that each file represents some denomination of token, example 1, or like something bigger. And I can interact in a few ways. Like I can expand and drag and drop like from this address folder to this one, and maybe here to this one. So yeah, and in background, it deploys transferring. So I actually transfer that denomination of tokens from my account to some external, my address to some external address. Yeah, and another small.
Let me interrupt for just 1 second. So while I'm not suggesting that file browser is the best way to interact with the blockchain, what I would say is that my 80-year-old mother is not well equipped to deal with the vagaries of, say, Coinbase or Kraken, but she certainly knows how to use her file browser. And what you just saw was affecting token transfers using a file browser. And now Andre is showing how to make change.
Yeah, can change to the smaller and transfer smaller part if needed. So this basic operation is tokens. Maybe I can show Block Explorer.
Sure, if you want. Yeah.
Yeah, of course, need some times to finalize that block that contains the transferring. perhaps it might take some times to finalize the block, and I can show some
Yeah, just
nice block.
show some of the Sankey diagrams.
Yeah, but I believe it's not finalized
Oh, okay. You don't
yet.
have, yeah, understood. So in general, this block explorer is built using Sankey diagrams, which are common in financial transactions, right? So the left-hand side represents a source address, the right-hand side represents a target address. If you had multiple transactions in a given block, it would show multiple sources, I mean multiple targets. And the width of the band shows the amount of tokens that have been transferred. I'm encouraging the team to show more than a single block in a page, so you can follow with your eyes the transaction flow. That hasn't been updated in a while, but so Charlie, you have your hand raised. Do you have a question?
I do. I just want to understand. I assume we're on a test net here, right? Or it's a
Yeah,
development.
it's like he said at the top. This is a local test environment that he's right.
Right. And so for that first part of the demonstration where, right, once this is live on a real blockchain that other people are interacting with too, and it's in production, then my assumption is that doing that file manipulation where you add an audio file or an image to the blockchain, that's going to have a cost, right?
Oh, it does now. It has a cost. It costs tokens to do that.
So the tokens were exchanged in that .tokens folder when those transactions
That's
were
correct.
made.
That's right. That's
Okay.
exactly. Yeah.
Okay. I think that there's some questions in the chat by other people too. I
Okay.
think
I'm
that that's
sorry.
what answered,
Yeah.
I believe. And again, I also had a question about whether FireDrive is Mac only at the moment,
No, no. Linux, Windows, all of it. That,
iOS, Android.
no, not iOS and Android. No.
Okay. All right. Thanks.
Yeah. Um, I think we've covered the bulk of the features here. Maybe at some point we'll come back and uh so Kabir, you ask a question. Can you speak?
Yes,
Okay.
I can.
Go for it.
But actually, I have two questions. One thing, I think I missed something about the tokens, but first thing is, so I can drop files onto the shard, which is basic blockchain. Does that mean that every node in the blockchain will have this file?
That's right. Yep.
Uh,
Every node in the shard will have this file. So a shard is a unit of fault tolerance. So if you don't want the files replicated, then you keep them in separate shards. That's
all right. So, but
just like
yeah,
inside Google, right? Inside Google, they cannot afford for the loss of a single node to cause the elimination of people's Gmail or the elimination of people's YouTube videos, right? So inside Google, they have replication, and the Google servers that are serving up YouTube are not serving up Gmail. So it's exactly the same as you find it in the enterprise.
okay. So, I mean, using blockchain for keeping files is probably kind of not the, I
It,
mean, sort of a little bit exotic use case, but
it,
probably it
it,
can be used if you have interaction between shards. So one shard could, let's say,
correct,
have
correct.
files, and
Yeah,
then you can access from other shards and so on and so forth. But now, regarding
that's the
tokens,
idea.
I guess I missed something. How do you exchange tokens just via file system?
Uh,
Like,
yes. So what he showed was that there's a hidden folder called tokens, and he can just simply
yeah.
drag and drop the token denomination files from one address to another.
You mean what is the one address? So
Go,
this
if you go back to the top level, Andre, there you go. Each top level file is an address.
and that is on like it's locally, or so how do I know an address of some other person?
Uh,
Or I see all the addresses in the shard. How does that work
you see the
in this
addresses
case?
in the shard. Yes, you see
All of them.
some addresses you can't get into, you can't look at the contents because you don't have the private key. Exactly.
Would you
Okay,
be
so
able
it
to
basically I
run?
can, yeah.
So again, I think people are thinking about blockchain in an old way. Blockchains do not, in the Firefly model, blockchains do not have to be public networks. They can be permissioned running inside an enterprise. For example, Santander, the financial institution, they are made up of multiple different companies. So Santander UK has to do reconciliation with Santander Europe. And for them to be able to do this kind of asset control would be a lifesaver. I know because I spoke with them about exactly this. In general, large scale enterprises are large through acquisition, even when a company has a big value prop. At a certain point, they grow by acquisition. Having grown by acquisition, their IT departments are fragmented, networks are fragmented, and having blockchains around each of those fragments makes a ton of sense for the enterprise. But they're not public chains. Maybe they put a shard out there that is public that can talk to their internal chains. But the sharded blockchain has a much, much more natural architecture. Okay, so Weaver's had his hand up for a while. Go ahead, Weaver. Weaver, did you have a question? Okay, Kabir, you put your hand up again.
Sorry, I was muted.
Mhm.
Can I ask my question?
Yes, please, go ahead.
Yeah, so just to make sure that I understand, when you move a file from your local file system into the shard, you have to charge it a priori with tokens.
Yep.
And the second thing, what happens if I make a few operations with the file and then its token repository is exhausted? What happens to it?
Then you can't do any further operations
Until I recharge it.
until you recharge it, correct?
Okay, understood. And last question is, if you're speaking about this network of shards, yes, can you create an hierarchical structure where a shard that contains other shards that contain other shards?
Yes. Yes, the short answer is yes.
Okay, thank you.
Sure. Kabir, you have another question.
Kind of a follow-up question regarding tokens. So so it seems like you can use basically file browser like a wallet almost. And then when you move this token file from one wallet to another, it actually registers in blockchain transaction. So what is actually, how this token is represented? It's like a file?
Yes.
How does that work?
Yeah,
That's my question.
Andre, can you put on the screen again the token directories? So what's represented on the screen are token denominations. So let's say again, at an address, this address, we had only 1,000 tokens. Then they could be represented as 10 100 denomination token files, like cash, or it could be represented as 100 10 token denomination files. And we have here, we've modified the file browser with an additional menu entry to be able to make change. So you can take a larger file and break it into smaller denominations, or you can multi-select a bunch of files and aggregate them. Does that make sense?
Barely. I mean, but
It's literally like a cash drawer. This is a cash drawer.
yeah. So I mean, blockchains are basically these distributed ledgers or whatever, where you have all the transactions of everything that happens in this case on the shard.
Mhm.
So where's this, and And here, I believe I see only my wallet, tokens in my wallet, which is just,
No,
list of
no,
cash or
no, no,
whatever.
no, 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 no. If you go back to the top level, Andre, right? Some of those addresses, you'll notice that they say locked or remote down at the bottom here.
Yes.
Those are other addresses that are not controlled by the user. So when he tries
So
to get in,
basically,
notice when he tries to get in, see, it challenges him. Do you have the private key for this? Since he doesn't have the private key for that address, he can't access any of the content. No tokens, no nothing. He can drop tokens in, but he can't get anything out.
yeah, so I'm fine with private blockchains basically, but suppose there's a case of public blockchain running on this. So you have like millions and millions and millions of addresses, and then you should have this ledger which combines all the transactions and you can see them. I mean, there's a block explorer. So I would like to understand how this block explorer picks all these things that are happening through the
So the block
system.
No. So the file system is merely an application. I'm not suggesting that this is the only way to interact. And in fact, we probably should move on, and that will help you understand a bit more. What we're really showing off here is the throughput of the system. Hopefully that makes sense, right? So the system has a certain amount of throughput that we're demonstrating using the file browser. But this is not the only way to interact with the blockchain at all. There are many other ways. And Charlie has his hand raised. Go ahead, Charlie.
I did have my hand raised, but it mostly was answered by your answer to Kabir, which is that I assume that if Andre opens up that tokens folder that we can see, he could take a token and just drop it in one of those locked ones.
Which
right?
he did. He
Okay.
demonstrated that earlier. Yes, exactly.
Okay.
Yep.
right.
Weaver, you have your hand up.
Yes, I have another question. As I understand, when you make you move in this example, you move a file from one place to another, you have to pay.
That's correct. You have to pay tokens. Yes.
Now, what happens if the file that I move is actually containing a very sensitive and lucrative piece of information, so everybody wants it and is ready to pay for it to be transferred to his local file browser, etc. So how do you control the flow of tokens relative to the operations that are possible on the system?
That's a great question. I really appreciate that question. So one of the things that the demo doesn't touch on right now, but it will do, is that you can wrap every single action, right? Notice that every file event is forwarded up to the FireDrive application. And the FireDrive application is free to run any Roland code it wants. Right now, it's running some very basic Roland code that gives you file system behavior. Right? So all the file system behavior you see here is written in Roland code.
I see. Okay, so it's all computer on the blockchain. It's not just a file system.
That is correct. And so if you want to do more fancy things, so for example, one of the things that YouTube does, as soon as you drop a video up into YouTube, it does a rights check. Do you really have the rights to David Bowie's Black Star? Or are you just some kid in Topeka, Kansas, trying to game system, right? So it does a rights check, and so we could write code that would go off to a subsystem and do a rights check. That would be an example of additional Roland code that we could do.
Yeah. Okay. Very cool. I was not. I guessed that much, but I was not sure. So.
Yeah. So there are lots and lots of problems to solve in this. And like you can imagine with a multi-platform application like this, that there are many things that we've had to do just to get it to this state. Once all the rough edges are out of it, then we will start demoing some very, very fun features.
Yeah, cool.
Yeah, awesome. Okay, so now we really should move on given the amount of time that we've got, because we have 3 other demos. Oh, Susie, you had a question. Go ahead.
There, I am unmuted. Just a quick question. So the file bytes are actually moved around
Yep.
and very large files, not an issue?
Not as far as we know.
Interesting. Okay, thank you.
Sure. Okay, so moving on, what you're going to see next is uh, to set the stage for what you're going to see next. Let me point out that we are attempting to integrate the Firefly software in all of the common workflows. So every day when ordinary people use their computers, they use their file browser, right? It's just a go-to tool for interacting with the computer. Another tool that has been a part of people's workflow for over a decade now are social networks. And so we are integrating Firefly with social networks. So one basic example that you're going to see is to take two completely separate instances of Blue Sky and use Firefly as a bus between them. Right? So that also demonstrates throughput. But it demonstrates another piece of the puzzle which you should have in the back of your mind, which is there is nothing special about that application. We can do the same thing for any Web 2 property. You can take the architecture of that application, which we developed primarily to kick off many such efforts so that people can federate and decentralize lots and lots of Web 2 applications. Right? We didn't just do this for Blue Sky. We also did it for Zulip, and it is possible for people to take what we've done as a template to do this for any sort of standard Web 2 stack, where you got Postgres in the bottom and then some business logic and then some JavaScript on top, right? You can take this architecture and federate and decentralize all of those applications. But that does not make the Firefly features such as tokenization or the use of AI available up into Blue Sky. So we've also forked Blue Sky and integrated tokenization so users can have wallets. And we've also added other features such as being able to define agents. So you can launch from Blue Sky an application that is codenamed Embers, which allows you to draw multi-agent systems in a sort of typical data flow diagram style, and then execute those. So that's what you're going to see next. You're going to see the integration of Blue Sky with Firefly. So over to you, Ihor.
Thank you. I'll share my screen in a second. Okay, so as Greg mentioned, here I'm running two independent networks of FireSky, basically our Blue Sky fork. So on the left we have Alice in first network, on the right we have Bob on the second network, and there is like FireSky shard that sits in between and synchronize them. So if we start looking for a user like network, we can see that Alice, despite the fact that she is on first network as well, present on the second network because it was synchronized. But for Alice's point of view, we are doing one directional synchronization. We can see only Alice, so there is no Bob. So basically, everything what Alice does, but everything what's happening on the first network will be synchronized to the second network. So we can go back to our users, and from Bob will visit Alice's page. And for Bob's point of view, Alice is completely normal user. Like there is nothing saying about that it's like coming from another network or anything. So Bob can, for example, follow here and interact like as normal user. And Alice, meanwhile, can do, let's say, create a post like so. So we have a post. It will be synchronized in a second to Bob. Okay, slightly more time. Yeah, here it is. So again, from Bob point of view, this is completely normal post. Nothing tells how it is like coming from another network or anything. And again, Bob can interact with it completely normal. So we can, for example, I gave it like and everything is fine. Any question, or I can proceed maybe to wallet functionality?
Yeah, let's go on to wallet because the first demo took a while.
Yeah. No worries. So we don't need Bob. Okay, so we integrated wallet functionality into PyRSky. So when you enter wallet page, you have two ways how you can interact with it. Either you add a wallet, for example, that was already created earlier, like this one. So as you can see, there is a wallet address, private key, token, balance, graph that represents change of tokens, and like a bit of history that I did a transfer earlier today. Another way you can interact with it is like create new wallet to prompt you for downloading key. And again, it was downloaded at the top. You can see completely empty wallet without any transaction, without any history, without any balance, without anything. And from this wallet, we want to copy wallet address and go back to the first one and check transfer functionality. So by clicking transfer at the bottom, you can set amount, set wallet address, add some node to user, and like basically transfer a bit of funds. For example, I want to transfer like this amount to this address. And just I will click transfer. Okay, it says transfer submitted. It's already was done. So as you can see, transaction history was updated with our transfers that we did basically a few seconds ago. And when we go to the second, to this wallet, we see that there is a change in graph saying that you got some money here, and this is your amount that you received from this address. Okay, any questions so far?
That's lovely. We are in the process of adding boosting to posts.
Yeah.
That's underway, but I'll let you continue. Go ahead.
Yes. So another big chunk of functionality is AI integration and agents and agents, etc. We have separate application for that called Embers. So again, when you open it, you need to log in with your wallet. That was this one. And here you can interact creating your agent teams. So now we'll do agent team. So this is basically a canvas where you can build your agent team using pre-built blocks and other, let's say, other agents, other users, agents that were built by other users. For example, you can reuse other agents. And the way you're building it is basically super simple by dragging and dropping blocks like so. So this block represents like abstraction around input. So it could be a message to your agent, it could be event on blockchain, it could be maybe some kind of RPC call, whatever, how you want to configure it. And for example, by dragging another part, we can connect it. So by connecting them this way, this input will be transferred to text model. And text model is current state is ChatGPT abstraction. So everything that goes here will be transferred here. And by adding more blocks, we can build even more complicated setups, let's say like so. Output. So in this setup, we will do like that. So we're taking input, we're transferring into text model, we'll transfer its output to text to image and text to speech model, and we will combine everything in compress operation and directly to output. So this is basically the whole flow. You are starting on the left, we are transferring input text model, text to image, text to speech, we're compressing everything and returning output to user by using this again output block. Another thing you can do before deploying, you can select few nodes and add them to deploy container. And deploy container is an abstraction around deployment where you want to deploy this code. For example, if you have a machine that is optimized for AI, maybe it has like very nice graphics card or something, you can select, let's say, those two nodes and choose that they should go to this cluster of machines that are optimized. But those are fine with general processing machines that are a lot cheaper and doesn't have a lot of GPU power. Okay, so we selected every node, we assigned every deploy container to every node, and now we can deploy them. While it's deploying, we can inspect the code that is generated. So here is an Roland that will be this was generated from the flow that we built together. So as you can see, there is like DALL-E 3 model that is text to image, text to audio model. We have ChatGPT somewhere. Cannot find it. Here it is. It is ChatGPT. And we do a lot of other stuff like saving the blockchain as address, etc. And if we go to node image, we can see that here's our code that we deployed. It was truncated, but we can see the block is created and added. So here we should see that deploys was succeeded, deploy is finalized, and we can now run it. So when I click run, we can go back to logs and start looking for change. So here is a log from ChatGPT saying that it was run and a bit of debugs, debug output. Now we are running DALL-E 3 and text image model in parallel, as you can see. Okay, text to audio is done, text to image is done. We have block created. And yeah, so block was created and added. So if we go back to our UI, we can see that we have a few more logs. So this is the output of the whole flow. So we have this part is coming from ChatGPT. As you can see, like description of human-like robot. Because I run it with asking to generate and to describe how robot would look like. And we have audio, it's like base 64 encoded, so it's truncated, and image of the robot. Here it is. So this is what text to image model generated for us.
So if I might jump in, first of all, thank you. That was a great demonstration and explanation. So the input node there was taking input from a file, which is why you didn't see him type in the input. So when we give these demos, we don't have to constantly type things in. And then it went off chain. The file was the prompt. The prompt went off chain to ChatGPT. That's the first text model. And then when the result came back, it went again off chain to the text to image and text to audio. And then all three results were compressed and then stored on chain at the output address location. So maybe that's not easy to see. So the part that's on chain is the orchestration, and the Rolang that was generated is the equivalent of what you might get from MCP or A2A, if you're familiar with those agent-to-agent protocols. So Rolang is now serving as a function for a agent-to-agent protocol. Any questions about that? Right. Did you have any more demo to show at this point, Ihor?
So I can do boosting, but
Okay,
but
If
I don't know if
we're a little bit tight on time, so maybe I think people understand
Yeah.
what boosting is about. But essentially, you can send tokens to posts. The next iteration of this demo, you'll be able to take an agent like this and install it back in as a user in the social network, and then you can send you can send messages. For example, you could send prompts to this multi-agent system just by posting to it on social media, and then you could fund it by boosting, right? So because of course running an agent costs tokens, and so you can run it. Go ahead.
No, just
No,
saying
Mike.
that that's correct.
Mike was asking a question. What were you saying, Mike? Go ahead.
Oh, I'm just saying it might be worth talking to everyone about how you get consensus on Oracle results.
Yeah. I mean, we've talked about that in Dubai a few times. If there are questions, we'll take that at the end,
Okay.
given how tight things are. Okay, so next up we have Dylan, who is going to show off the Meta compiler.
Can you hear me okay?
Yes.
All right.
Did you come on and leave and come back so we can see your screen? Let's find out.
Yeah, I'll see if it works this time.
Okay. Aha, it worked.
Good. Maybe this. I'm gonna move this out of the way. The toolbar. There we go. Okay. So can you see my screen okay?
Yes.
All right. Let me see if I can make the font size a little bit bigger. So the biggest will go. Why is it changing? Well, is the font size okay for everybody?
It's okay for me. I don't know about everyone else.
Okay. I'm trying to increase the font size for the keyboard shortcuts, but it's not.
It's all good. It's
Oh,
fine.
okay.
It's bigger than the others.
Yeah.
Okay. Okay. So here I've made some changes to the robot planning demo based on the progress we've made in the compiler. So you see here, well, this is trivial. Meta compiler now is here at the top, like before. I think that's been introduced here. I realized the state needed to, or the state wasn't being persisted correctly across the invocations to the robot API calls. So I've moved that up to the top. Then within here, you can see, so this is the VS Code language server integration with Rolang. So I've added support now to detect when meta code snippets are being evaluated with or being compiled with the Metatron compiler, and just using some basic graph flow deduction. And so it sees that this particular string snippet is being sent on the code file channel, which is then passed to the meta compiler. So then it deduces correctly that the string that is being passed as the message consists of metacode. So it semantically highlights now the snippet of metacode within the string. And you also get some helpful LSP features like like go-to definition and such. So this will help just ease the development pains of in developing meta-based applications within Erlang. So then, as before, I defined the initial facts. Here's the graph of which rooms are connected to each other, the locations of the items within each room, the initial location of the robot, and the initial state of the robot is carrying nothing. Then you have your queries. So I've updated them now. We have some support for match, some support for catching errors. And I won't go through these all of these in too much detail. But then we have some pathfinding rules and some additional helper functions to help flatten out the results. This one just helps find the minimum or reorder the results such that the plans that return the minimum number of steps are prioritized. We need support, or we once proper support for extracting values from path map with pattern matching is implemented for Erlang. A lot of this will become a little bit easier. Here, these distance calculations are in terms of hops. Then we have some transportation planning routines. Then if we go down, so here we have, this is where I'm defining the individual API calls. So we have the persistent state. And then here, what we're doing is, so this is a rolling contract, which accepts the parameter from room. In this case, it wants to find all of the connections coming from this room. So it wants to see which rooms it's connected to. So you have the room, you can construct your Erlang application just with string concatenation or the particular query. And then compile that and evaluate it. Then you have your results. Send the results on the return channel, and then you print the results or do whatever you want with the particular results. The other API methods operate similarly. So for instance, you have a transport object, which calls it invokes the transport object rule. And then we call these API routines within the demonstration. So the first one, we want to, this one just dumps all the neighbors of a particular room. For demo 1, demo 2 wants to locate ball 1, find where it is in among the possible states. Part 3 wants to find the shortest path from room C to room A. These are just sort of demonstrating some of the logic among the rules. The more interesting one really is the last one. So if we go down to demo 6, what it wants to do is transport a particular box 2, which is currently located in room B, and I want to transport it to room D. Starting with the robot's initial state of being in. So the robot is initially in room A, and it is carrying nothing initially. So room A is connected to room B and room E. So when we run this, now if we look at the results, you can ignore these error maps. These are coming from some of the catches for the non-deterministic paths are not completely filtering out these error nodes. So that's a fix that'll be implemented here shortly. But if we go to the plan, here's the objective. Transport box 2 from room B to room D. And now we have here, go down to steps. So step 1, navigate to room B, because room A is connected to room B. Then pick up box 2. Then this one goes back to room A, and then from room A to room E, and then from room E to room D, and then it puts the box down. That's one plan. I believe there's another one for this one. But anyway, so if we look at the results then, so we go So room A is connected to room B, then room B is connected to room A, then E and D, and so forth. And it just follows the graph that we have constructed
Yep.
here.
Yep.
So are there any questions on
Any
this?
other major features that you want to show off? Or, oh yeah, it's time for questions. Good. Any
Well,
questions?
so yeah, a lot of the features are demonstrated in how these rules are updated. And then the LSP integration.
So I think one of the impressions I want people to take away is that there's seamless integration between Meta and Rolang. You can write applications that freely mix Meta and Rolang. When you're running Meta, it's the state isn't transacted in the sense that in the way that Rolang state can go off to the physical store. We're in the process of fixing that, and that will be a part of the next release of the compiler as we get more involved with MeTTaIL. Given that we're at the bottom of the hour, I own this room, and this is where the meta semantics meeting is, so we can steal some time from the meta semantics. And it's a good thing to do because we have Christian up next, who will describe his progress on MeTTaIL. Christian, over to you.
Hi, yeah, thanks. So share. Everybody see that?
Yeah.
So so wouldn't it be great if you or your agents could work in many different languages seamlessly, or even define your own language on the fly in response to problems? And so basically, people have been doing some really cool things with meta programming in Rust, in addition to being a very fast, and well structured language. It also supports meta programming. So one library that I found a while back is called Ascent, and basically you can write data log directly in Rust with access to all of Rust's rich types and functions. And then it just generates an efficient logic engine from the relations and rules that you define. And so, so for MeTTaIL, there's a similar idea where we can define essentially a programming language from types and basic operations, equations that the operations satisfy, and basic rewrites for execution. So this is row calculus, kind of the simplified or the simpler language underlying Rolang. And it's built out of these operations and runs with these rewrites. And basically from this little bit of code, the macro, this metaprogramming thing, validates that your language makes sense, and then generates everything that you need to actually work with the language, parsing and actual execution and many other things. So this is just a little bit of the logic part of the code. There's other code that is generated here. It's actually it's quite a bit of code, but Rust compiles it very quickly. And let me just skip to an actual demonstration of it. So just to emphasize, you could have defined whatever syntax you want for your language, and now the rewrites are actually executable. So there's a little REPL here where you could load a particular language, such as row calculus, and it shows that it has successfully loaded. And there's a bunch of like example contracts or programs that you can run. And so now you input one of those programs, it parses it, and then it just ran a whole logic program that was cranking out all the possible executions of that term, as well as any other predicates that you wanted to define in the logic program for any kind of analysis. So here is the example program. And then if you want to explore the graph of execution, you could say show all next rewrites, and it shows the branches out. And then you could choose one of them, and now you're on this new term, and you say show the branches out of that, and you can explore the execution. So that's yeah, this is the idea, is that it could really be this simple to define programming languages in a way that now these programs are actual data structures, well defined in Rust, that can be passed around by other Rust programs. And you're basically setting up you're making a setting for integrating many different languages. And this same idea, you could even in the future, we will even have a macro for translations between theories, so that you can compile or translate programs between each other. So
It looks like Charlie has his hand up. Charlie,
yeah.
do you have a question?
Yeah, I just close to an hour ago, Greg, you mentioned that one of the desires Ben had was to have programmable types. Is this the
Type
route
system.
forward here?
Programmable type systems.
Yes.
Oh, well, in my opinion, it is. So Ben thought that if you had sort of a malleable language, then you could kind of enforce a bunch of things from the type system onto the language, and get different kinds of semantics just by changing the type system. And while that's true to a certain extent, you can't have the type system coax the language into doing something it could never do before.
But you could just generate as many different languages with different type systems as you want using these tools, right?
Yeah. So the spatial behavioral types go the other way. They say from the model of computation, generate the spatial behavioral types. So if you and that is a bit more along the lines of what I think Ben really wanted to do. I know that Esther jumped off and a few other people jumped off. Albina jumped off. So thanks to all the people who could make it this far. But yes, so this gives you the ability to auto-generate the spatial behavioral types. Nabuyu, please go ahead.
Hi.
Sorry.
Yeah, no problem. My question was on MeTTaCycle. I didn't get a chance to ask that. If I could right now, if you finish their presentations.
Yeah, so we can, there's a few more things to talk about, but go ahead. What's your question?
Yeah, so I had like these three other, Hyperon components built using Meta, right? So I wanted to build some way of secure communication between those components. And I was reading about, the documentation on map and MeTTaCycle, and that uses Erlang and tokenizations to communicate, the secure tokenizations to communicate, to initiate communication to these types of components. So I just want to ask that, is it possible to use it in Meta or directly in Meta, or do I need like a Erlang definition, or do
No,
I need to convert them to
you can-
Erlang code?
So what Dylan demonstrated before was a Meta to Erlang plus path map compiler. So you can take your Meta code and embed it in an overarching rolling harness, and you will get the desired secured communications.
Right, so it's like an API call, kind of.
Something like that, yeah. Yeah.
All right, thanks.
So if you've joined our Discord, hit up Dylan Edwards and ask him. I'm sure he would love to see your code as a test case for his compiler.
Definitely.
Yeah, sure. Can you give me a link to your Discord? Thank you.
Sure, absolutely. Let me go ahead and do that now, so anyone who wants to join can join. I think I sent you one before, but I'll grab it again. 1 second here.
Is all as many real world applications and examples as you have for Meta. Whatever you can provide me would be greatly beneficial toward helping us rapidly develop the Metatron compiler.
There's an invite in the chat for anyone who would like to join our Discord. I think Kabir also had a question. Kabir, what was your question?
It was a little bit involved and not much related, but I wonder, do you have a system which allows you to build hierarchies of shards and permissions between them, and how do they interact? Because it seems to me that this
Yes.
is
Yeah,
kind of
yeah.
the next step.
We've asked that question, and the answer is affirmative, yes.